Hey guys, so in this video, we will be looking at an example from your handout, which talks about valuing a frozen pizza manufacturer. So this is the question number 6 from handout number of chapter number 13. So there's a pizza manufacturer and two business graduates or entrepreneurs or venture capitalists, whatever you could think about, are considering purchasing this frozen pizza manufacturer. So some numbers, sales numbers are given as 10 million for the upcoming year, and the operating costs are roughly 70% of sales. Depreciation is given as a percentage of sales, tax rates given, and the new annual investment in equipment every year is roughly 5% of sales. Okay, and the growth rate is in perpetuity at 4%. And on the basis of their analysis, and they want to finance this firm, like when they try to buy the firm, with 25% debt and 75% equity. So the required return on the debt, they can borrow at 6%, and they want an equity return of 15%. So that's the required rate of return on the equity for Bowers and Isabel. And the tax rate is given again, and the risk-free rate and the market risk premium are also given to you. So the first question is, what is the maximum price that they should be willing to pay for the premium pizza? So this is an example of a simple valuation problem. And I did work out the numbers earlier, and I will be going through these numbers soon. So the first thing is, it's actually the sales, and all these values are given. And from these values, whenever you're trying to do a discounted cash flow analysis to value the firm, you want to be able to get the actual operating cash flow, not the net income. So you go from the sales all the way down to calculate the operating cash flow. So when you worked out through these numbers, 10 million, 70% is the expenses, depreciation is 5%, 0.5 million, the earnings before interest and taxes are 2.5. The taxes would be given as 0.875, and the net income is 1.65. So this is the operating cash flow, which you could try and think about it for all the shareholders in some sense, and the bondholders as well. So this is the operating cash flow which is available. And from this, the investment cash flow is given as 0.5 million per year. And the overall free cash flow to the firm can be estimated as $1.625 million. And so this free cash flow grows at a rate of 4% in perpetuity, and we will be discounting this free cash flow using the weighted average cost of capital. So in order to calculate the WACC, the weight of debt is 25% and the weight of equity is 75%. The cost of equity, which is required by the two students or the two graduates, Boris and Isabella, is given as 15%. And the cost of debt is also given as 6%, and from that you could calculate the weighted average cost of capital at 12.2%. So once you find out the weighted average cost of capital, the value of the premium pizza, since it's a growth in perpetuity, you'll be using your perpetual growth model, and the free cash flow is divided by the weighted average cost of capital minus the growth rate, and that gives you a value of 19.9 million. So in this scenario, for these sort of returns, expected returns, and this is their borrowing rate for the two people, they can value the firm at 19.9 million, and that's the maximum value they should be willing to pay. Ideally, they would want to be bidding at 15 million or 10 million or whatever they can get the firm for. That's the value they get. And the second part of the question relates to the same valuing the same firm, but from another perspective. Where it's another grocery chain, and the grocery chain's equity beta is given to you, and its cost of debt is lower than what Boris and Isabella could, because of course they're a much bigger firm and they could borrow money at a much cheaper rate. And this firm wants to buy this firm at like 40% debt financed, and it also has a 35% tax rate. So what will this firm be able to purchase this pizza manufacturer for, or what's the maximum price which they will be willing to pay? And so once you try and go about that, the weighted average cost of capital, it's in the food industry as well. And for this particular firm, once you actually calculate the weighted average cost of capital, the cost of equity is found out to be 8.6%. And this is a big difference, 8.6% for this big food manufacturing firm versus 15%, which Boris and Isabella wanted. And because for them it's a much bigger risk, and for this food manufacturer it's a much lower risk, and they require a much lower cost of equity. And this brings their overall weighted average cost of capital to 6.46%, which is much lower, almost half of the weighted average cost of capital for the previous scenario. And once they have 6.46%, if you use this weighted average cost of capital and again do the free cash flow divided by WACC minus G, the value of this particular firm comes to around $66 million. So the maximum value, you could tell how in the first scenario they value it around 20 million, and the second scenario they value around 66 million. So this is primarily just due to the cost of financing and the lower volatility and the lower cost of equity for this the shareholders of this particular firm, Fresh Foods. And this is how the discount rate, in some sense, the denominator impacts it in a much more concave manner, if you could try and think about it, or convex relationship. So here, it's 20 million, but you reduce the WACC by half. This does not just double; it goes up by like more than 3 times in some sense, right? So that's not a linear relationship when you reduce your discounted cash flow rate in some sense. And that is it for this chapter, and the rest of the questions from the handout we'll be working out in class tomorrow.